So this is what I call the supplement. This is just, well, I don't call it, that's what they call it there. And this is the section that you can keep. And anything on these things can be on a test, right? You understand? So y'all are required to, I had an instructor when I came to Bessemer State. His name was Jack Walters, and he gave out handouts, hundreds of them. And anything that was on those handouts could be on the test. So if you didn't read the handouts, you're in trouble. So there's starts off with a few terms, guys, that y'all need to understand. So these can actually be on a test, right? And then so what we're going to do is we're going to actually look at the first lab, which is the one I just gave it to you. By the way, guys, if you don't think you're going to lose these things, you need to probably leave them in the drawer on your lab, right? These are all available on the internet, so if you lose them, then what are you going to have to do? Yeah, our copy budget last year was $100. You know how much we spent so far? About $200. And we're not even through with the term yet. So this gives a discussion, but let's make it talks level switches detect and respond to liquid levels. We already know that, but there is a term they use in here that's pretty interesting. Talks about system interfaces. So this is on page LC7. And we already had experience with this, right? We know that most solid state sensors are not designed to run a heavy load. So usually the output on our solid state sensors, we're going to be dealing with milliamps. We're not going to be dealing with amps through those simulated contacts. So what can we do to get more current when a sensor senses something? We've used it already quite a bit, huh? Sorry. Add another one. So what do we use? We got one contact. Okay, so I've got a sensor that runs off 24 volts. I want to control a motor that runs off 120 volts. My motor requires 15 amps. My sensor can put out so many milliamps. What would we use between the sensor and the motor? I'm kidding. We'd use a relay. And we've done it all kind of times already. So what we would do is we'd use the sensor to energize a relay. So I could have a relay rated, and this happens in your house. How much voltage do they run up to the thermal? Most of the motors in your HVAC system runs off 240 volts. What do they bring up to the thermostat in your house? What's the control voltage on just about all HVAC systems? 26 volts. And why? 26 volts. Yeah, that's real safe. Right? You understand? So all my electronics inside there runs off DC. All the relays inside my little control cabinet runs DC. All the relays that run your motor are AC relays, right? Right? You understand that? So what we can do is we can take something that puts out milliamps. We can use that to pick up a relay coil. And what are the contacts of a relay rated at? They could be AC, it could be DC, right? You understand? They could be rated at 500 volts. It don't make any difference. And current, the size would be the current and the distance would be the voltage. And this is what these guys call an interface device. This is what you do to go between, to make connection to the outside world, right? You understand? So most of the time when we go outside in the power section, the power section is going to be relays, right? You understand? The control section is going to be a lot of relays than ours. But normally in PLCs, your control section is nothing but a program. But still, your power section is going to be relays, right? You understand? So if I needed to go from DC control over to AC power, I could use a relay. If I needed to go from 26 volts to 240 volts, which is what your HVAC system does, we use a what? We use a relay. So this is what the guy refers to as an interface device. An interface device not only allows us to change the amount of current, it allows us to have, what's the normal, how many contacts, simulated contacts, does most of our solid state sensors have? Every one of them that we've used this term, how many contacts do they have? Simulated, because we've been dealing with solid state. We just now got to our liquid level. These are actually mechanical contacts. These are reed switches, right? How many contacts have they had so far? 1. What if I need 10? We would use the sensor to bring in a what? Right. Okay. What if I need to run that motor right there? It's 240. Well, the sensor could bring in a motor starter if it could. If it can't, we can use the sensor to bring in a relay, a control relay, and it can provide the current to bring in a big motor starter. So relays, they can refer to that as the interface between the what? Between the sensor and what are we trying to control. So there's very few things that we control directly with our sensor. There is one. What have we done so far? What do we control directly with our sensor so far? Besides a relay. All we've controlled is these little light bulbs, right? You understand, those require almost current at all. But as soon as we moved over to the motor starter, we did what? We let our sensor bring in a what? A control relay, and then we used the control relay to bring in the motor starter. So a control relay does things for us. It allows us to change the voltage level that's required by the load. It allows us to provide more current than our sensors can put out. And also it increases the number of contacts that's available on our sensor, right? You understand that? Everybody okay? Any questions on that? So that's what they call an interface device, and that will be on the test. So system interfacing, that's what it says. Control switches such as push button, temperature switches, liquid level switches are designed to switch the lower amounts of current so that the electrical contacts are not damaged. They can safely switch small current loads such as lighting, such as control relays, such as small solenoids, right? You understand. And then what does it say? It says an interface device allows what? 2 components that have different electrical ratings to be interconnected. That's a really, really good explanation. In PLCs, they call these field devices. So these are the guys that actually the PLC, so the PLC very seldom runs a load, a true load, the guy that's doing the work. A PLC would bring in a relay or something like that. So this is what they're showing us here. So converted level switch. So this tells you how to take our liquid level switch and convert it from a normally closed to normally open. Right, but I think I already showed y'all that right when I brought it up here. But that, you can forget that. And of course this tells us this is our first circuit. So how does the circuit work? So it looks like we're using a selector switch. We have a push button. We have a normally closed liquid level switch. We're going to use that to bring in a control relay, and then the control relay is going to bring in a motor starter. It's going to run our motor. So how does the circuit work? What happens when I put it in the hand position? Y'all remember how to read these things? So the solid line tells us which contact is going to be affected. So the solid line says this top contact is going to be affected. And then the dashed line says the bottom contact is going to be selected. So when we put it in hand, then the top contact is going to be closed and the bottom contact is going to be open. So as these things have normally closed or normally open, it depends on the position of the selector switch. So when I got it in the hand position, that means I can control the pump manually. This is very, very popular because a lot of times you have to do things, right? You might have to empty the tank out of your system and the limit switch don't let you. So we have the ability the float switch doesn't let you. So we have the ability to override it and turn the pump on. So when I switch it over to the auto position, then now it's being controlled by a liquid level switch. This liquid level switch is going to be mounted toward the top of the tank. This is what we call a charging control system. So what this is going to do is going to try to maintain the tank at a certain level. Not between a certain level, at a certain level. So that means when liquid goes up and fills up, it hits the float switch, it would open up, right? You understand? And as soon as it starts dropping down, it'll do what? It'll close, turn on the pump until it raises up. So this is going to be a very, very short range. We're going to figure out how we're going to take this out. This thing has problems with oscillation. Because if you get anything inside the tank that's flopping around, your liquid level switch starts doing this, your motor will be going like that, right? You understand? So we'll look, how would we take care of that? Well, we'll probably just add a timer. So that'll be one of the circuits that we do. So this gives us a manual control, and this gives us a automatic control. Everybody okay on this? And of course, you're going to have to measure current and do that kind of stuff too, guys. So we're not going to go over that. Everybody okay? Then down here in B, it says redraw the control circuit in figure 6. So you're going to have to figure this out on yourself. And what you're going to do is you're going to add a red lamp when you're in the hand position. So you're going to have to figure out how to do that. Also add a green lamp that is on the selected switch in the auto position. You need to figure out how to do that, right? Everybody okay? Very interesting. Remember. Okay. Well, lab 3, lab 3 on this one, they're going to give us the circuits for lab 1 and lab 2, but lab 3 is always going to be a what? It's going to be a design.
So every lab 3 is a design.
Yeah. I'm just making sure there's nothing in here. So it looks like that's it on this lab. So y'all can make notes on these, right? They're yours. What you need to do on the lab is go ahead and put your name on the top of it right now, so you won't what? Forget and lose 5 points when I grade it. So this is where I want you to put your name, right? We do have some, we do have, and it's a pretty good idea too. We do have some students put their name on everything. Yeah, what's that nice about that is that if that staple ever comes loose and this thing comes apart, you have the ability to know who belongs to who, right? And this has happened, by the way, guys. So any questions on this? So y'all look it over real quick and see if y'all see anything in there y'all want to ask a question about. So we're going to start off with a charging system, then we're going to move into a discharging system, and then we're going to move into a two-level system, which means two-level means it's going to, so two-level, the discharge is going to be when it detects it's empty, right? You understand? Charging detects it when it's full. Two-level control means you're going to maintain it between what? Two levels. So you'll turn the pump on when it's low, then you'll build it up, and when you hit the top, you'll stop, and then you'll let it drop down to the low level, turn the pump on. Are we okay? I think I think it's lab 2, which we'll go over later. When y'all start getting close to it, we'll go over that one and make sure you understand how that one works. I think that's the one where you add a timer in there, so you keep it from oscillating.